Hello and welcome to the fourth lesson in the first unit of Math 2. This lesson is going to be all about domain and range, so hopefully it's mostly a review, and there's just some little bits and pieces that we can talk about. Okay, by the end of this lesson, I'll be able to find the domain in different forms of functions and be able to find the range in different forms of functions. Alright, so the domain, the set of all first elements of a coordinate pair, the x values in which a function exists. And this word right here is the key word we're going to be talking about today. Where does it exist? Do I really have something there? The range is the set of all second elements of a coordinate pair, the y values in which a function exists. Once again, we're going to talk about that exist element. A discrete graph is a graph or data that consists of only points. If something is continuous, it's a graph or interval that is continuous in a way that you can draw without lifting up your pen or pencil. I know that sentence is really horribly written. A graph or an interval that is continuous, it should be period there, is one that you can draw without lifting up. That makes me feel better. There are no holes, gaps, or jumps. If it is written in interval notation, it indicates a span of numbers written in parentheses or brackets. So this is a key here, parentheses or brackets, from smallest to largest. Set notation indicates a group of single elements or values that are classified the same, meaning they're all individuals from one another. No particular order is necessary. Where in interval notation, smallest to largest, typically anything we do in math when we're doing some sort of notation, we usually try to make it in numerical order from least to greatest. Okay, so what is a function? A function is defined as a set of points where one input has only one output. So where one input has only one output, that's key. A good test for this is the vertical line test. Let's see. Let's kind of just talk about that vertical line test real quick. I'm going to come over here to another page. So I'm going to draw a graph right here. And let's say I have some function. Okay. To be able to determine if this is a function, I would take a vertical line. If it lets me write, there we go. Take a vertical line, imagine that's straight. If that line is touching more than one spot at a time, notice it's only touching right there, then it would not be a function. If it's only touching one, it's a function. So we're okay. This is a function. If I were to have a graph and we had something like a circle, right? And I took this vertical line. Notice I'm touching in two spots. So this would not be a function. Okay. If that makes sense. Although you can find the domain and range for a variety of graphs and tables, we'll focus on finding domain and range for functions in this class. We're going to talk a lot about functions this year, not so much about expressions or non-function things. Alright, so just notation, just a review. So remember, parentheses and brackets we use for interval notation. So these are boundary points that the domain or range will approach, but they'll never touch when we're using parentheses. So that means all points between those boundary points are included in the domain and range. So everything in between. So essentially what you're going to have, let's say I had two parentheses and said 3 to 15. Any point between 3 and 15 is going to be included in this interval. It exists. At 3 and at 15, those I'm going to call those boundary points, is what you're going to hear the terminology that in my class. At those boundary points, it's going to get really, really close to those points, but it's never going to touch those points. So 3 does not exist. We don't have an input value for 3. We won't get anything out. Same thing for 15. Where brackets, the exact same thing happens, but if I have a 3 and I have a 15, I can now have points that equal 13 and points that are 15, whether we're talking about domain and range. It means those points are included. Where braces, and you guys are going to laugh at me a whole bunch during this video while I try to draw some braces. Those are used when the domain and range are specific points and are all listed. So these are specific points, where before, up here with parentheses and brackets, those are all interval, so they're boundary points, where braces are going to give individual points. And let's see what we're talking about. So remember that there are many ways that functions can be represented. This is a visual relationship right here. Throughout this lesson, we're going to look at many different ways that they can be represented. So if I look at this visual relationship, in this function to the right, you can define the domain as the set of all the inputs that are possible. All the inputs that are possible. And you can define the range, set of all the outputs that are possible. So first of all, I can see domain is my inputs, where the range is my outputs. First of all, I know this is a function because each input only has one output. If I had a multiple arrow going from this, that is where I would not have a function. So let's get rid of this. Okay. Alright, so to determine the domain of the following and range of the following function. So the domain is simply all of these points. So I'm going to draw one of these little braces. Notice, super not good. We get -1, 0, 1, 2, and 3. Look, that almost looks like a brace, that 3 value. Okay. The reason I had to do braces is because I don't know if there's something between -1 or 0 or 0 and 1. So I have to do each point individually. And we do the same thing for the range. In this case, we just list all those. 3, 5, 11, 21. Okay. Each one individually. We do the exact same thing as a table, or with a table. I have my inputs. We have our outputs. Okay, so the domain is going to be the list of all inputs that exist. So we have 0, we have 1, we have 2, we have 4, we have 5. Okay, and then my range is simply all my outputs that exist. 1, 4, 7, 13, 16. It's alright. Okay. I'm just simply looking at inputs and outputs. Okay, functions as coordinate points. Same exact thing. We're looking at which inputs exist, which outputs exist. Okay, so let's look at this. Anything in red is going to be my input. Those are my x values, where everything I'm underlining in green are my outputs. We're looking at what exists. So my domain, anything that exists, is 3, -2, 0, 6, and 4. And remember, order does not matter. Oh, that was a half decent one. Could be a lot better, but we'll take it. And then my range is any output that exists. 7, 5, 8, -7, 7. Okay, those are all my things. And really, I didn't have to list 7 twice. I probably could have cut that out. Okay. So discrete graphs are graphs that are made up of entirely individual points. Notice I don't have anything connecting these. That's what we could call this as discrete. So when finding the domain and range of these discrete graphs, we have to use the x values of the points and the y values of the points to be able to determine the domain and the range. If something is continuous, it has no holes or jumps, we can draw without, let's try and get a good thing where I'm not underlining these words here. We can draw without picking up our pen or pencil. If a point's filled in, then a graph is still continuous. If a point is empty, then the graph is not continuous because there is a hole in the graph. So if we notice all these points are all filled in, we can draw this without picking up our pen or pencil, so we know it's continuous. A discontinuous graph, it has holes, it has jumps, or discontinuity somewhere in the graph. When we draw it, you will need to pick up your pen or pencil in order to draw it. So notice right here, see how that's empty? We call that a hole. And this big space right here, we call that a jump. Okay? So to draw this, I'd have a filled in hole. I have to pick it up, I have that hole. Well, this filled in, that would be not a hole, that's part of the graph. That means that that point is included, where a hole, like right here, that point is not included, so we would not have something there. Alright, so now we want to try and find the domain and range of this graph. So first of all, before I do anything, I'm going to notice anything. I have a hole right there, hole right there, and we have a jump right here. Okay, so we're going to write the domain here. So domain, I'm going to say, I'm always going to start, I have a line connecting stuff, so we're going to use brackets and parentheses and all that good stuff. I'm going to start from my lowest term, and we're going to talk about domain, which is talking about my x-axis here. Okay, so what values of x, or my input, are included? Okay, so I noticed down here this graph that I have this arrow, so that means I'm going to start at negative infinity. We have to use the parenthesis because negative infinity is not a number, it just means it goes on forever, so we're going to go to there. Then I look and I'm following along here, and then oh, I got to this hole, so I got to -2. I used a parenthesis there. Okay, and then it starts back up again, up until I get to 1. But I notice, look at this 1, I have this jump in this hole, but I do have a value for 1, so we're good. So I'd start at -2, at 1 we're good, we're going along, 3, there's 3, 4 over to infinity. And I'd use a parenthesis. So my domain is I have all values from negative infinity to -2, not included, and then from 2 to infinity I have some value for x that exists, if that makes sense. Okay, I'm just going to erase some stuff real quick. I'm going to erase this line. So we're going to kind of trace this along as we go. Okay, so now we're going to do a range. Okay, my lowest point to the upper point. Okay, so I noticed down here, I'm going to start from my bottom point. I could start at negative infinity. I'm going to use a parenthesis. I notice I'm going up. I have a value, I have a value, I have a value. Oh, right here though, I have a hole. I have a hole over here, but look at all these other values for -1. So we're still good. Keep going up, keep going up, keep going up. Notice same thing that's happening with this jump. I have values over here, so I can keep going. Same thing with this hole. I have a value, so it exists all the way up to 3, and I can use a bracket because it's going to stop at 3. 3 exists. So that's my range. I hope that made sense how I explained that. If not, come talk to me and we can talk about it some more. Okay, so find the domain and range. Each of these points are right there. Okay, so we're going to look for domain first. Okay, so I'm going to start right here at my lowest point, which it looks to be 0. I'm going to use a bracket. I'm going to go along the graph this way. I'm going to say, oh, yep, I have stuff, I have stuff, I have stuff, I have stuff. Oh, that's where I have to stop at 5 with a bracket. Okay, let's do the same thing for the range. I'm going to start at my lowest point. Right there at 0, it looks like. Bracket. As I'm drawing along, I'm looking to see if there's a point that equals it. Yep, I'm good, 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 I'm good. And we're there. Over, up to 50, and we're included. That's all we're doing. Okay. Now I want you guys to try. Find the domain and range. So pause the video real quick and determine domain and range. Alright, so hopefully you tried that. If not, let's look at this video. So first of all, notice I have all these points. So we know this is a discrete graph, and it tells us, that helps us. So if I'm doing domain, I notice I only have points here, 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 and here, right? So I know I have to use braces. You guys can laugh at my braces. We have a point at 0, 1, 2, 3, 4, and 5. 2, 3, 4, and 5. Okay? Now we do the same thing with the range. I notice that I have a point here at 10, 20, 30, 40, and 50. So once again, I have to use my braces. So I have a point at 0, point at 10, 20, 30, 40, and 50. Ooh, that was a solid brace right there. Okay. Last domain and range. I'm going to identify my inputs because I want to know which inputs exist and which outputs exist. So I have a table, so I have to use braces. I don't know if there's stuff in between. So I know 0 exists for an input, 1 does, 2 does, and 3 does. And then I have my outputs. Ooh, half decent. 1, 3, 5, and 7. Okay, so those are the ones that exist. If you have any questions on domain and range, please come and talk to me. I'd be happy to help you. Thanks.